These are the essential parts of any C program. In this video, we will learn about the recursion. Simply we say when a function calls itself, it is called recursion. But in this video, we will see in which condition a function calls itself. And to illustrate this recursion thing, I am typing a program to get a value for the factorial of given number. You know, factorial of 3 is 6, factorial of 5 is 120. To evaluate such factorials, I am going to type a program. See the program. In this, I take a variable under the name keyword name int n, and obviously we show the user the message to enter the integer positive integer. Okay, thereafter, as soon as the user sees this message, he enters the value, and to scan the entered value we use scanf function. %, you know, a value is stored at an address, so here %. Okay, thereafter we use a function. So first let us declare a function first. You know, the function is declared below the last header file. If there are several functions, then these are declared according to their desired run. So I am here declaring a void, that is it will not return anything. Function name is fun, and here int 2 times. This means that this function will take 2 arguments. So here you see inside the parenthesis 2 int. Okay. Now after declaration, we come again inside the body of main function, and here we type fun. There will be 1, n. Inside the bracket you see 2 things, 1, and n. These two are called actual arguments. So there are 2 arguments. First is 1 and second is n, the integer itself. Now it comes the time to define the function. For that we use the same type, it is void type fun, and here there are 2 arguments. So int, suppose first is a, and int, suppose you may take second m. Okay, now as this is a function definition, so there is no need to type here semicolon. Now as you have passed, these 2 are called actual arguments. You have passed 1, here is 1, so the value of a will be 1, and the second argument is n, so the value of n will be equal to this value m. Actually, the value of copy of n goes through this function. Here these 2 arguments are called actual arguments, and here these two arguments are called formal arguments. Now we update the value of a equals to a equals to a into m. This means that initially you see a is 1. Why it is 1? Because this is the first argument, and you inside the main function the actual argument corresponding to this is 1. So here will be 1. And what is m? Suppose you enter the value 5. So that 5m will be equal to 5, and now a will be 1 into 5. So when it comes inside the fun function for the first times, a becomes 5. Thereafter we call the function again, and this time we take a, but a is updated, a is not 1 this time a is 5, and here we take the second formal argument m minus 1. M minus 1 obviously will be 4. When this function runs for the second time, a was 5, so here will be 5, and m minus 1 at the place of m, you see here is m, so here is the same thing m, so here is m minus 1, 4, then that 4 will be multiplied. Earlier it was 5, so 5 into 4. In this way it will go, and this is the part due to which we say it a recursion, because you see that this fun is inside the body of this fun function. This whole thing from this point to this point, this whole thing is inside the body of this function, and you see that the same function appears inside this body, so it is called function is calling itself. Function is calling itself. When it happens, it is called recursion. Okay, now we get our result, but here is the problem. Problem is that function is calling itself, so function after running will come here, and since it is calling itself, so it will be again here, after that here, so this will continue forever. This means that our program is not going to end. To end this program, we have to use a base condition. Always remember, whenever you use recursive call, then there is always a base condition to end the program. So for that, to end the program, we use if and if else, and when m is decreasing after each run, after each recursive call, first it was 5, thereafter it becomes 4, and it will go in a decreasing, and at last it will be 1. So at 1 we have to end the program, otherwise we have to make recursive call again and again. So accordingly I am typing inside the parenthesis m not equal to, this inverted line, vertical line with dot is called not here in C program. M is not equal to 1. When m is not equal to 1, then you have to do this thing. We can cut this thing, and we can paste here. If not n is not equal to 1, then we have to make recursive call again and again. Else, if suppose after decreasing it becomes 1, so we use the else keyword, and we have to print the result obviously, and you know our result will be this thing, this A, because in A is regularly updated. First it was 1, thereafter it becomes 5, thereafter it becomes 5 into 4, thereafter it becomes 5 into 4 into 3, thereafter 5 into 4 into 3 into 2. That is our result. So we have to print A to get the factorial of inserted number. So I type a printf, and here the message, the factorial of given number is %d, and you know % is the format specifier for the integers, and you know factorial of a number is always an integer, so %d here, and here I have to type A, because at the place of %d the value of A will come, and which is our result. So I think our program is ready. Let us see whether it is working or not. Yes, it is saying enter the positive I, insert I, and pressing the key enter. Okay, it is working. You see here the factorial of given number is 120. So in this program I have used recursion, that is a function calling itself, and obtained the factorial of the inserted number. You can insert any number and get the factorial of that. You can pass, here you see 2 arguments. One can pass 3 arguments as well. Okay, I show you. Here you see 2, I am inserting one more int. Okay, so accordingly here you have to insert 3. Suppose I am inserting n again, and here accordingly I have to take 3 formal arguments. Here I take int p, and the program will be more beautiful if I change this argument. Also here will be 3 arguments, a, m-1, p. Suppose p, I am not changing p is always the same. So here we can write %d factorial equals to %d, and for the first here %d, this means that the number you entered. So here will be p, because you entered for n, this n, and this n will be copied here. This means that this p is our n, so I wrote here p, and the second %d is for the result. Result is given by this a, so the second will be A. Okay, I think it is okay. Let us run this program. I have changed. See the change. With this program you see two programs actually. The first one I showed you earlier, I have shown you earlier, and the present one is the second program. So you see it is saying enter the positive number. This time I am entering 6. You see factorial 6 equals to 720. Okay, thanks.